So we're back again with video number 2. Let me start my timer over so I know where I'm sitting at. All right, so we're back again. We're trying to answer this. The first question I want to answer is there some sort of greater probability of the dealer busting based on the card showing? So the way that we're going to do that is I'm going to write a dealer strategy, and then I'm going to give them a card, and I'm going to find out what happens as we go through as I simulate that thing, right? So that's the idea behind it. So let's go ahead and so I'm going to do a 2, a 3, a 4, a 5, a 6, all the way through an ace. And I don't necessarily need to worry about a jack, queen, king, because they have the same value as a 10. So I'm just going to throw a 10 in there. Okay. But we will come back to this. I'm going to hit shift enter on all this stuff. I'm not sure if I did that yet. All right. So we're basically sitting back where we were at the end of the last video, except for now I have this new little cards, right? So we're going to do each one of these a whole bunch of times to find out what happens. But first I got to write a dealer strategy. So dealer strategy, I'm going to give it a hand and a deck. And then, so val is equal to hand. So this thing that we just wrote a few minutes ago, this blackjack value, right, should come out. So while value is less than or equal to 16, then what do we want to do? I want to deal a card. So deck dot deal hand, comma, 1 card. And then val is simply equal to the new value of the hand, right? So once I give it a card, I want to find out how much those are equal. So val is equal to, and then that will eventually allow us to exit out of the while loop. So hand dot bj value, right? And so it'll go in there and do that. And then all we're going to do is then return a couple things, right? So we got to return the hand, we got to return the deck, and we got to return the value. Well, we don't have to, but we could, because we could just simply tell it to call the value again. But if you have the information, why don't you just or send it back? Okay, so this is the dealer strategy, shift enter, so we can do that. And now what I want to do is I want to create this the simulation that will use that dealer strategy and these cards and sort of find out what happens, right? So I'm going to do a sim game. So I'm going to simulate a game. Tell me how many you want, and then tell me the card that you're passing in for each one of these. And I got to create a little data structure that's going to capture whether they busted or not. So again, I can make one's a busted or one's not a bust. I think in my mind, I'm trying to capture the percent of time that busted. So maybe I let or maybe we let busted be zeros. Maybe 1 means that you have to play them. Okay, so we'll do it like that. But I have to create a data structure that will capture this, and so we'll say np dot zeros capital N, right? So I'm going to do this n times, and then for I in range n. Don't try to do length of n because that won't work. We just found that out a few minutes ago. That is going to be equal to deck dealer equals to a hand, and I'm going to go ahead and do a player as a hand too. I'm going to go ahead and deal cards to a player, and the dealer is equal to deck deal underscore card dealer comma card, right? So I'm going to give the dealer this card that we want them to have, and then deck dot deal. Then we're going to deal 1 to the player. I'm going to only deal 1. I'm going to do a deck dot deal 1 back to the dealer. Deal them 1, and then deck dot deal back to the player. Deal them 1, and then deck comma dealer comma deck comma val is simply equal to dealer underscore strategy dealer comma deck dealer strategy, dealer is the hand, deck is the deck. Okay, so all that makes sense. And then if val is less than 21, then we want the result I. So right now they're all zeros, and then I want to turn res I, result I, into a 1 if it's less than 21. So that means the zeros are bust and ones are not bust. So I'm going to average the number of times that you didn't bust. So lower numbers are better for the player. So that's the idea behind that. And then we'll return the result. So just right now, I'm going to print, let's see, I'll print dealer just to find out what happens, to make sure that it's doing what we think it should do. Shift enter. And then we'll say sim underscore game. I don't know, 10 of them. And then cards 6. Didn't like it. None type has no attribute cards. None type has no attribute cards. Deck.deal. Deck equals deck. Oh, so let's see. Oh, in here. So deal. I passed in player 1, so that should have worked. And then it went to the second one, and I got dealer. Hands.cards.append, self.draw, return hand. So none type. So obviously I set this equal to something where I shouldn't have. Am I returning anything in deal card? Let's see. Deal card. I am not. So let me get rid of that. I mean, I guess we could return the card, but I'm just gonna do that. Shift enter, shift enter. All right, that's better. So because I didn't return anything, it was setting it equal to num type is all that was happening there. But I don't need to really return anything. So 8 and jack is, oh, so the 6th card must be an 8. So let me make sure that's true. 1, 2, or 0, 1, 2, 3, 4, 5, 6. So the 8 of spades is going to be in there all the time. And then the jack, so I didn't have to hit 8. So that was a bust. So 6 and 7 is 13 and 8. That makes sense. That's a bust. That makes sense. 8 and 4, 12 plus Q. So that's another bust. That's 18. So it's not. 19 is not. 18, 18. 9 and 8 is 17. It is not. And the last one is 13 and 8, which it is. Okay. So it looks like it's doing what we want it to do right now. So I'm going to take out that print statement. And now I'm going to create, I don't know, a whole bunch of these suckers so we can do it, right? So I'm going to say n is equal to maybe 10,000. I want answer to equal np dot zeros length of cards. So what am I going to do here? I'm going to capture the number of times that was the number of times that was busted, and then answer underscore e is equal to sim underscore game capital N, which is the 10,000 right now, and then I forgot to do something here. So for I comma C enumerate cards. Yes, np.zeros is the length of cards. That's good. So M comma C, right? Because I'm getting the C out of cards and I'm getting the index out of cards. And so then answer I equal to answer underscore C dot mean. So let's talk about what this thing's doing. So just like when I ran this simulate thing, right, it gives me a bunch of 1s and 0s. And all I'm asking Python to do is or NumPy actually, is give me the mean of those numbers, right? So that would be 1, 2, 3, 4, 5, 6. So that would have been 0.6 for this one. Just note that, right? Because I would have had 6 divided by 10 would have been the mean, and then I would have gotten 0.6 for this one for the 8. Now I'm running this 10,000 times for each one of these. I'm going to go ahead and hit Shift Enter because this might take a while. Print. I'm just going to print answer and see what happens. Messed up. I got the print statement in there somewhere. So it's just going to take forever to do. I'm going to hit kernel, restart and clear output. So I need to go back and find where the print is in this thing. Oh, I must not hit this again. All right, I got to start over anyway. So Shift Enter, Shift Enter, Shift Enter, Shift Enter, Shift Enter, and so on and so forth until we get to that. Print a bunch of stuff out. It just takes a really long time for it to print to the screen. That's why I want to sit here and wait, because it's going to take enough time to do 10,000 of these for each one of those cards, and then to print us out with the probability of it busting. All right, so now what we have is, so given that you got a 2, you got a 51% chance of busting, a 50%, and so on and so forth, right? 50% chance of not busting is what this is. Okay, so let's just do a little bit of matplotlib. So I got 11 minutes, so I'm almost done. Matplotlib.pyplot plt.bar. I'm going to throw a bar plot out there. np.arrange from 0 to length of answer, and then comma answer. Answer plt.show. Get out of the way. All right, so we see now I got zeros here. I'm going to put the tick marks as plt.xticks np.arrange length of answer. All right, and then I'm going to put that's the str of c for c in cards. And now come back up here where wherever I had cards, that's going to be a 2 of spades, 3 of spades, 4 of spades. So I want the string representation of that. Let's see what this works. Yes. Okay. So 2 of spades. It looks like if you got a 2 of spades and you have, this is the sort of the probability of not busting, right? So I got a 40%. It looks like a 5 is worse than a 6. And I think that's been true throughout the time that I've been messing around with this. So anyway. All right. So now you know, I mean, if the dealer has a 7, an 8, a 9, a 10, even an ace kind of looks like it has a high probability of busting, but any of these other numbers, you can go for it. Try to not bust because you have a higher probability of the dealer busting. All right, that's all I got. And the next one of these that we do, we will look and see sort of a very minimalist strategy. I'm not going to get too heavy into it, but just give you how you could possibly sort of do a little bit of research and figure out if there's an easy way for us to up our chances of winning. Okay, see you next time.